The first test is always important. All right, so let's go ahead. We're going to do the odds now, so stay with me. I gave you some time. Continue on the odds. Let's see what we're doing. 6 more than twice a number. 6 more than means plus 6. Twice a number means multiply by 2. So it's just 2n plus 6. All right, 2n plus 6. Anybody have any problems with that? All right, now we're on number 3, Colton. All right. No. I want you on task. All right.
2 divided by y plus -7.
Okay, that's nice. Quotient means 2 over y. That's a division problem. That is added to -7. So technically it should be -7 plus. All right. You're adding the quotient to -7. You're adding the quotient to -7. You really got to think about that. All right. Any questions with number 3? What?
It wouldn't be 2 divided by 1 plus 7. It doesn't say like.
If I said 3 is being added to 4, what's being added, the 3 or the 4? That's why it's 4 plus 3. It's the same situation. What is being added? The quotient is what's being added. Do you agree with me on this now? All right. And unfortunately, when you add, the order in which you add doesn't matter. So it's not going to be a different answer if you put it in the reverse order. Do you agree with me? But if it was subtraction, it would be wrong. Okay. All right, let's check out number 5. Now here, again, I tried to remind you, 8 times the sum. Those are 2 operations in a row, which means parentheses. So go ahead. What would it be?
8 parentheses n plus 3.
Yes, there you have it. All right, 8 parentheses n plus 3. All right, now number 7. There you go. Yeah, because you're all right. I'm trying to make it so it's not just remembering things. All right, so I'm going to take 8 and I'm going to multiply it by something. Do you agree? I'm going to multiply 8 by the sum of these 2 things. Do you agree with me? So I need parentheses because if I don't have parentheses, it'll just multiply the 8 times the n and not the sum of n and 3. Now, let me ask you this real quick. What if I said, what's 8 times the sum of 2 and 3? What would that answer be? 8 times the sum of 2 and 3. Yeah, but I want you to say, well, the sum of 2 and 3 is 5. 8 times 5 is 40. You see what I'm saying? Yeah. So I'm trying to show you that they want you to add these 2 first, right? That makes sense now, right? All right. Here we go. So now number 7 is the same thing. Go ahead, Luke. Thank you, sir. 10 parentheses n minus 5. Very good. All right. Let's try number 9. Again, the same thing. All right. 4 times the sum of a number f and 8. 4 parentheses f plus 8. All right, for number 11, it says that a conveyor belt travels at 8x feet per second. After 45 seconds, it moves how far? Tell him.
45 seconds.
You are amazing. That is a good job. 45x. All right, if it's going to travel x feet every second, right after 45 seconds, you're just multiplying those two together. All right, everybody good? Let's go to 13. Laura is 5 inches taller than Sam. Laura's height is L. Then Sam's height is what? Come on, guys, this is kind of tricky. Palmer,
L minus 5.
you are good. Laura is taller than Sam, so Sam is shorter. So that would be L minus 5. Very nice work, Palmer. All right, now let's quickly do some order of operation here real quick, guys. Come on, everybody's up on 15. All right. Sadie, tell me about 15.
5 times 2 and then you get 15.
You are amazing. That is correct. 15. All right. Mr. Greet, you're up. Number 17. What do I have to do first, bud?
25 minus
Which is? And then what? Which is? Good job. 6 times 10?
72.
72. Wow. Good job, buddy. Good mental math. All right. Anybody have any questions with 17? All right. Let's take a look at 19. All right. Miss Lupin, you're up. What do I do first?
6.
What's that? You're great. 90. Very nice.
I got flex.
Thank you, girl. That was a good job. 198. Good mental math. 198. All right. Here we go. 3 to the 4th. We all should know 3 to the 4th. Listen to me. Let me help you. 3 to the 4th. Don't do 3 times 3 times 3 and do 27 times 3. Do 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. All right. 81 plus. Everybody knows 4 squared is. Now the hard part. 7 to the 0 power. Say it. 1. Anything to the 0 power is 1. What's 1 to the 4th power? 1, right? 1 times 1 times 1 times 1. And what happens to minus 1 and plus 1?
Cancel out.
Yes. So what's 81 plus 16?
Yeah.
97. All right, good work. 23. All right, now we have a little bit of trickiness. So come on, everybody's looking up. Division of fractions. What do I do? No, multiply by the reciprocal. We don't keep, change, flip anything. All right, it's the same thing, but you want to sound better. You don't say keep, change, flip. Say multiply by the reciprocal. Plus 5 6 times 2/15. Now we cross reduce. Does everybody remember that? Right, so here we go. 5 goes into 5, 5 goes into 5. So the fraction on the left is 3/4. 5 goes into 5 once. 5 goes into 15 3 times. 2 goes into 2 once. 2 goes into 6 3 times. So now we have 3/4 plus 1/9. Anybody have any complaints about that so far? Yes, sir.
Let's get 1 9.
Well, what did you get?
Drop 3 is 5 and 15.
That goes in 3, right? 2 and 6 goes in 1 and 3, right? 3 times 3 is 9. All right, now when you're adding, I need a common what? All right, we need common denominators. What's the common denominator here, guys? 36. 1 fraction bar, 36. And now I multiply the first fraction by what? 9. So that becomes a what? 27 plus multiply the second fraction by. So that becomes a 27 plus 4,
41.
31 over 36. All right, good mental math. Yes, quickly.
Oh, wait, I think that was an 8. I think put 3 over 8, but something.
You good? All right, let's knock out 25, guys. All right, someone help me. What's the property for 25? Caroline? Yes. Commutative property of addition. 27. Well, you're looking at 26. Jump to 27.
sorry.
That's all right. Don't be sorry. Don't be sorry. It's all right. You are awesome, girl. Multiplicative identity. Good job. All right, Evan, tell me about 29. You remember? What are we doing with the 3? Tell him, Jay. Yeah, distributive property. The distributive property. 31. Greep. 0 property. Very good. Okay, hold on 1 second. Sorry, go ahead. Which one? Most of the time, I would say yes, that's pretty accurate. Okay. All right, number 33, Mr. Wash. I tried to trick you on this one. Yeah, because it's out of order. Do we agree? All right, so be careful with the order. Commutative property of addition. All right, 35, sorry. Yes, this is an inverse. All right, multiplicative inverse. Very nice. Great. If things cancel out, it's an inverse. If they stay the same, it's an identity. Do you hear me on that or not? The 2x and the 2x. You with me now, right? That's the easy way to remember. Inverses, things are canceling. All right, Katie, help me out. 37, what is this? I'm on 37 now, not 36. Integer, what? Yes, integer, rational, and real. Integer, rational, real. Did they get it fixed? All right, integer, rational, and real. 39, let's go. Who haven't I heard from? Go to 39. Are we on 39? I know, that's why I'm reminding you. 39 is what? Yes, irrational and real. Thank you very much. Palmer, help me out with 41. Square root of 36. What is that?
Natural.
Very good.
An integer, it's rational and it's real.
You're amazing. That was a good job. Square root of 36. Underneath that, everybody put 6 down. All right. Sunshine, 43. What's square root of 2? Square root of 2. What, classify it numerically? What number set does it belong to?
Oh, natural.
No, it's not a perfect, a square root that's not a perfect square is irrational. Do you hear me? Square root of 2 is not a perfect square, so it's irrational and real. All right. Now, 45 is supposed to be a trick question because what's negative 32 divided by 16, guys? Negative 2. All right. So, Suri, what is that? It's integer. It's integer, rational, and real. Very good. All right, now we're translating into equations. All right, we're not solving, we're just translating. All right. So again, Number 47. When a number is divided by 10, so x divided by 10, the result is subtracted from 9. So 9 minus that equals 1. That's what we're doing. Sorry, I'm going to blow that up a little bit. There we go. Anybody have any questions with that? That was very tricky. If I say 3 is subtracted from 10, what's 3 subtracted from 10? What's the answer? That's why I reversed the order. You with me on that? That's a good, yes, you could say that. All right, here we go. Yeah, here we go again. 5 subtracted from. So that's going to be minus 5. Minus 5. It's subtracted from what? 3 what? 3h. All right. 5 is subtracted from 3 times the number h. Oh, okay. There's a typo here. 5 subtracted from 3 times the number. No, there's not. I just misread. Is means what? Equals 7 more than 5h. There you have it. All right. $51. The sum. That means we're adding 2 things. The sum of 1/3 of number j, so that'd be 1/3 j, and 2 is means equal 3 more than j. All right, that was kind of tricky also. All right, now we got to get into some more arithmetic. All right, here we go. Let's double check 53. What's the absolute value of -3, guys? 3. 3 minus 6.
-3.
-3. All right. Now, is this an absolute value sign right here? No. All right, so just make sure you're aware of that. That's not absolute value. All right, let's look at 55. What's the absolute value of -5/8? 5/8 minus, what's the absolute value of 5/6? 5/6. There you have it. All right, so now we're adding and subtracting fractions, so I need a common denominator. What's my common denominator here? 24. Multiply the first fraction by what? So that becomes 15 minus the second fraction multiplied by what? All right, and I end up with what? 20. What's 15 minus 20? -5 over 24. All right. Now for 57, am I adding or subtracting these fractions? You're adding them, correct? Now, for me personally, I think sometimes it's easier to just say, what's 3 plus 5? So I have -8 to start out with, correct? And now I'm just adding 1/3 plus 1/4. Common denominator is what? 12. Multiply the first fraction by, second fraction by, final answer of that fraction when I add them, 7 over 12. So now I just put that back up there. -8 and 7/12. Everybody good with that? All right, let's do another fraction. Now, am I adding or subtracting these fractions? Now, these you have to be careful with. Come on, I need eyes up here because I have to borrow for this one, I think. All right, so if I'm subtracting, first of all, remember I told you, is the answer going to be positive or negative? Negative. Make sure you put the negative there. Then I just come down here and I just write the subtraction. 6 3/8 minus 1 4/5. Remember, you put the larger number on top. Now, what's the common denominator with 5 and 8? 40. Thank you very much. So I have to multiply the first fraction by what? 5. So that makes that
15.
multiply the second fraction by, so that becomes, now does everybody remember, can I subtract these now? No, you have to borrow from the 6 and make it a what? Now, what do I do with the 40 and the 15? Add them. Come on, guys. Very good. Very good. So that's 55. Now we can subtract. And when we subtract, we get what? How much? What I'm asking you what 55 minus 32 is. What's 50? 23 out of 40. And then 5 minus 1 is 5 minus 1 is 4, right? So my answer is 4 and 23/40. And don't forget it's negative. All right. Now that's the one I wanted to really go over because most kids forget how to borrow with fractions. All right. For sure, that's going to be on the test. All right. Now here, same principle. All right. We're subtracting 7 2/3 minus 4 5/9. Is my answer going to be positive or negative? All right. Good job. It is in fact going to be negative. All right. And I'm really trying to help you. If you forgot how to do the fractions, make sure you're with me. Common denominator here is what? 9. So this one's good because do I have to borrow? No. All right. So this 7 minus 4 is 7 minus 4 is 3. 6 minus 5 is 1. So it's negative 3 1/9. Negative 3 1/9. Everybody's good with that, right? Okay. All right, let's see if anybody can do this. Identify the graph that displays the speed of a baseball being pitched and then hit by a batter. What are we thinking? Why C?
Starts slowing down, so it's the batter hits it, so it's speeding up there.
Anybody else? What are you thinking? Why? Oh yeah, he said C. What do you think? C. Do we agree with that, right? Right, the ball is being yeah, they kind of messed this one up too. I should have looked this over. All right. Let me come over here and I'm going to show you a better graph. All right. The ball is in your hand when you throw it. How fast is it going? What? When the ball's in your hand, it's going fast? No, it's not, right? Is it going at all? No, so we're going to start at 0. Then you start to throw it. Is it getting faster? Yeah, as you throw it, gets faster, right? Now, believe it or not, when the ball hits the bat, how fast is it going when it hits the bat? Say it again. It stops. Believe it or not, you don't see it, but the ball actually what? It actually stops when the ball hits the bat. Do we agree? So it would have to look like this. Boom, comes down here, straight down. All right. Then when the ball leaves the bat, it what? It goes really fast. So this would have to be something like this. All right. And then eventually the ball is what? Is slowing down. All right. So it goes out quickly and then it starts to what? It starts to slow down as it gets to its height. And then it comes back down. It should look something like that.
So was it A?
Wow. You're correct, girl. It was A. All right, that was good. All right, but I don't like the way they just leave it open-ended. All right, that was good. All right, Mr. Williams, that was good to know that the ball is 0 when it hits the bat. All right, very good. All right, let's check out 65. Okay, during a snowy day, it snowed lightly for a while, stopped for a while, snowed heavily, and then stopped. Which graph represents this? Now, all right, tell me which one. Yeah, definitely A. But I would also like when it stopped, I want everybody to put a dot there. All right, it would stop. All right, now does everybody understand it stopped for a while? It goes horizontal. Do we agree with that? All right, that's why it was A. All right. Let's knock out 67. Which relation is a function on 67? Mr. Grieb, good for you.
A.
A is the answer. Very nice work, buddy. Very good. Come on, no daydreaming. We're doing really good. All right, let's knock out 69. How do I do 69? What do I do? Come on. Come on, someone. Evan, what am I doing? What do I do with this 4 right here? Yeah, you put it in 4x. So I want everybody to put f of 4 equals. So what's my answer? That's correct. Okay, we're going to write 71 as a set of ordered pairs. What are the ordered pairs for 71? 1, 9, 5, 7, -4, 2, -6, 2. All right, they asked for the domain, correct? So right above here, if you want, you can just say domain and what? Range. Domain is the set of what? X values, and the range is the set of Y values. All right, I'm pretty happy with that. 73, is that a function? Is 73 a function? Why not? There's 2 5s. No. All right, let's look at 75. Is that a function? Is that the same problem? Yeah, there's 2 73s. Oh, that's what I did wrong. Sorry, that was the same. All right. Okay, how do I find f of 2? Tell me. That's right. Very good. No, you can just write -2. I was just making that very good though. All right, g of -1. Who's got g of -1? Greep.
Either -1 minus 2 times -1 to the second power.
You are amazing. So what do I have to do first here, bud? Yeah, so what is that?
It'd be
Yes, it would be because no. Well, -1 squared is 1, right? And then 1 times -2 is -2. You happy with that? And then of course, -1 minus 2 is. Come on now. Don't miss this part. -1 minus 2. You owe your mom 1 and you owe your dad 2. Yeah, think of money. Think of money. All right, now f of 7 minus 9. So I have to find f of 7, and then I subtract 9. So let's come over here and say f of 7 equals 2 times 7 minus 6. 14 minus 6 equals 8. And after I do that, I do what? Minus 9, which equals what? -1. All right, guys, I'm super happy about today. That was a good job. Hopefully you feel good about that. All right, in the other class, I'll do what? The evens, and then I'll post it over the weekend for some of you guys who want to double check your work and make sure you got all this. All right, for your test on Tuesday. On Monday, I will go for questions. All right, really good job today, guys. Really good.